Now, of course, the A levels are very, very definitely big on the idea that you can recognize what they call chiral carbons, what we call stereogenic carbons. So important that we practice this here. In fact, this question really is certainly A, B, and C A-level worthy. So anyway, let's draw them out. So the first one there, CH3, CH2, CHCl, CH3. Looking at this, the only possibly interesting carbon might be this one right here. That's got a hydrogen, chlorine, and 2 carbons on it. All the other ones have at least 2 hydrogens on them. So let's expand that out. Carbon's got a chlorine and a hydrogen. This group over here is an ethyl group, 2 carbons. This group over here is a methyl group, 1 carbon. So we can see that indeed this carbon has got 4 different groups attached to it. So it would be a chiral carbon. 3-methyl hexane, drawing it out like this. All of the carbons except this one have got more than 1 hydrogen on them. This one here, we got a methyl group, a hydrogen, and then it's expand out the rest of them. As far as this carbon is concerned, this is an ethyl group, and this is a propyl group. So draw it out, we've got ethyl, methyl, propyl with the hydrogen. So 4 different things on that carbon there, thus it is chiral. 2-bromopropane, there we are, well again, multiple hydrogens on 1 and 3, so the only possibly interesting carbon is carbon 2 that has a hydrogen and a bromine and a couple of carbons on it. However, in this case, when we're thinking about being carbon 2 there, this is a methyl group, this is a methyl group, so therefore 2 identical things, 2 of the same things on that carbon, thus it is not chiral, so there's not a chiral carbon in this one. Now the cyclohexanes can get kind of fun. Let's draw out methyl cyclohexane. So obviously all of these carbons here dead boring, but this carbon here, carbon 1, has got a methyl group and a hydrogen, and then it's got a couple of carbons on them. Well, these 2 carbons are actually the same, because if you start at this carbon and you go 1, 2, 3, 4, 5, you come back to the original carbon without anything funky at all. This carbon here, if you go this direction, 1, 2, 3, 4, 5, and you come back to the original carbon. So both of these groups, if you like, of this carbon are the same, so therefore no chiral carbons. We get to 1,3-dimethyl cyclohexane, it's a different matter. Obviously these 2 carbons here could have 4 different groups on them. So we got methyl, we got a hydrogen. Now starting here, we go on this left carbon, we have to go 1, 2, 3, and then carbon 4 is the other funky carbon. However, going this direction, carbon 1, this carbon here is the funky one, so we only have to skip 1 carbon to get to the funky one in this group. We have to go 1, 2, 3, skipping 3 to get to the funky carbon in this group. So this group here is different from this group here. Thus this carbon is chiral. Same thing for this one down here, in exactly the same measure. Hydrogen and methyl, 2 carbons, you have to go skip 1 and then you get to the funky carbon. This one here, 1, 2, 3, and you get to the funky carbon. So both of those carbon atoms are chiral. Both of them are stereogenic. Draw 2 enantiomers of 2-bromobutane. We can use abbreviations, that's nice, using wedges and dotted lines, and label drawings as R or S. Well, first of all, there's 2-bromobutane. I hope you would agree that this carbon here, carbon 2, it's got a bromine, it's got a hydrogen, it's got effectively a methyl group on the left and an ethyl group on the right. So it is indeed a chiral carbon. So therefore we can have enantiomers of it. Now let's make it a little bit less cluttered, shall we? So focusing just on carbon 2, we got bromine, we got the ethyl on the right, we got the methyl on the left, and we got a hydrogen on the bottom. Now, of course, if we are to assign things as R or S, we need to know the priorities. So obviously bromine is priority 1, hydrogen is priority 4, but of these 2 carbons that are bonded to the chiral carbon, this one here is just a methyl, this is an ethyl. This carbon only goes to hydrogens. This carbon also goes to another carbon. So that makes that the methyl, the 3rd, and the ethyl, the 2nd priority. So what we're going to do is we have to draw it so that it's obvious which direction we're going in this priorities. Now, lots and lots of ways to draw things, but for me the easiest thing is to just start off with the structure we've got and say, well, if we think of a tetrahedral carbon, 2 groups are coming out at us and 2 groups are going away from us. So just to make it fun, I've drawn it this way. So I've said the bromine and the hydrogen are coming out at us, the ethyl and the methyl are going away from us. Okay. Now, at this point, those of you who are really au fait with the material can say, well, okay, the hydrogen is coming out at us, so the general rules are flipped. Bromine 1, ethyl 2, methyl 3, so we're going clockwise, but because the hydrogen's coming out at us, that makes that the S. But it's always useful to have models. So let's make a little model of this one. So bromine and hydrogen coming out at us, bromine green, hydrogen that's sort of grey. Ethyl going away from us, that's that blue. I apologize that I couldn't quite match the blues with my drawing program to the blues with my model kit, but you can see that those are blue, and these ones here, pink and purple, I figure pink and purple go together. So there's the bromine, there's the ethyl, there's the hydrogen, and there's the methyl. Now, of course, the rules are easier to follow when you say let's put the lowest priority group, in this case the hydrogen, away from you. So I'm going to do, and I debated making a movie of this, but I thought, no, you can visualize it by this stage, I hope, is I'm effectively just going to move that hydrogen round to the back, bringing the bromine towards me to give me this picture. So I've just brought the bromine towards me, hydrogen at the back. Now let's see what we've got. The bromine is number 1, the blue ethyl number 2, the purple methyl number 3. 1, 2, 3. I'm going anti-clockwise with the hydrogen at the back. That makes that the S isomer. Now for drawing the R isomer, well, the easiest thing to do is just reflect this in a mirror plane. So let's do that. So bromine coming out at us at the top, hydrogen going away from us down at the coming out at us, down at the bottom. But now instead of the ethyl being on the right, it's on the left. The methyl is on the left here and on the right there. So this should be the R isomer. Well, let's make sure that that is in several ways. First of all, hydrogen coming out at us, that's the lowest priority group. So whichever way I go is opposite. So 1, 2, 3, I'm going anti-clockwise, but of course because the hydrogen is coming out at us, anti-clockwise means R. Let's draw the models. So there we are again, bromine and the hydrogen there kind of coming out at us, methyl on the right, ethyl on the left. Let's rotate it so the hydrogen is going away from me, so that just means rotating it so the bromine comes towards me. So there's the hydrogen going away from me, there's the bromine towards me, there's still got the blue ethyl on the left, got the pink or purple methyl on the right, hydrogen going away, bromine number 1, ethyl number 2, methyl number 3 going 1, 2, 3 clockwise. So therefore, because the hydrogen is going away from me, clockwise is the R isomer, the R enantiomer. Hope that made sense, and do play with model kits. It's really the only way to get a good feel for organic chemistry. See you in the next one.